All right, good morning. Today we are solving systems by graphing. Okay, so just a little bit of overview. A linear function is just a straight line, and the equation for it, they're in the form of y equals mx plus b, okay? Then you have quadratic functions, which are in the shape of parabolas, that U shape, and they are in the form of y equals ax squared plus bx plus c. Okay, so what we're going to do is we're going to graph a linear and graph a quadratic, and we're going to find the solution. Okay, so basically we're going to find solutions where the line and the parabola intersect. Okay, so we're going to graph them, and we're going to look at the two to see if they touch at all. Okay, if they touch each other, then we say there is a solution at the point that they touch. So if they only touch or intersect one time, then they only are going to have one solution. If they intersect or touch each other two times, then they have two solutions at the two places where they intersect. And if they never intersect at all, okay, something like this where they're never going to touch each other, then there is no solution, okay? So let's look at our first example down below. All right, so the first one we have is what is / are the solutions to 2x minus 3 and y equals 3x squared plus 2x minus 6. Okay, so what we're going to do is we are going to go to our best friend, Desmos.com, and we're going to put these two equations in, and we're going to look at the graphs for both, okay? All right, so on Desmos, if you type in your two different equations and then you look at the graph, your solutions would be where the two intersect. So we have two solutions because our blue parabola crosses our red linear function two times. So here's one solution at -1, -5, and here's our second one at 1, -1. All right, so you could see on Desmos.com that the 2 points of intersection were -1, -5, and then 1, -1. So we had two solutions. All right, so we're only going to do these three examples, and then we are done. Okay, so what are the solutions for y equals 2 and y equals x squared plus 2? So you can see I have our linear and our quadratic. We're going to graph them to see where the two intersect. All right, so you can see we graph both equations, and you can see when you graph it that they only touch one time, and that one intersection point is 0, 2. So that is your solution. So based on our graph, we could see that there was only one point of intersection, so there's only one solution, and that one solution was 0, 2. Okay, so we got the two equations. If you look, you're not seeing the point show up, but if you click on one of them, you'll see the gray point appears for where they intersect at 4, -6. And then we have to scroll down to find our other one, which is at 3, -15. All right, so then for these two, we saw that they had 2 points of intersection, which were at -4, 6, and 3, -15. So we had two solutions. And then we'll move on to this last one, okay? So we're gonna go to Desmos and type both of these in now to see what our solution or solutions are. All right, so we graphed the two. You can see they're not touching. And if you scroll up, you can see they start getting further apart, right? So around here was the closest they're gonna get. And then they just start getting further and further apart, which means these two will never intersect. So our solution is no solution. There is not a place where these two graphs will ever touch each other or ever intersect. All right, so based on when we graphed these two, we could see that they would never intersect, which means our answer was no solution.